Hey guys, thanks for coming back. Today we're going to work on that tube compression collet and the nut that holds it in place and tightens your tube down. So let's get to work. Hey guys, thanks for tuning in again, and we're on to the next step here. Basically, there's a couple things I want to do first. I want to make a couple little changes, and that is mainly because I was downstairs looking through the tooling I already have, and I have a great 7-degree uh, angled or tapered end mill. So I think we had built our collet taper here for 12 degrees, which would require a 6-degree tapered end mill. I already have a 7-degree, so let's go backwards and see what we can do to change that up and make life a little easier. And what is going on here? Why is our... I haven't been in here since the last time we played, so I'm not sure. Ah, okay, no, that's the collet there. Okay, so let's go back to this shape, which comes from this combined function. That's that. There's our sketch. Okay, this is how easy this should be, but I could be so wrong. Let's see if we go to 14. Okay, that just made it a little shorter. Not a big deal. And, all right. See what it looks like underneath. Pretty perfect. The only other thing I would do that I was thinking about was to recess this lip because, well, let me show you before I do it and why I'm doing it. Turn on the side analysis here. Okay, so if you picture the wedge here as the collet nut that threads on the outside here, pushes the collet upwards. It pinches this taper in, which gives you the friction that holds the tube in place. So, and now the way I'm going to build this collet or flexure or whatever you want to call it is I'm going to leave the very top is just going to be a solid ring all the way around with the 8mm bore and the OD that fits in here. And then I'm going to slot from this line down either 4 slots or 6 slots. I'm not sure which yet. And there's going to be a just straight cylindrical part on the back of the collet that's going to pocket into here. But if it pockets in here and it seats against this lip, then the collet itself can't move upwards at all. And if it can't move upwards, it can't compress inwards. So I want this dimension to be a little deeper than the actual collet's going to be. And the reason I'm leaving this ring on the end is for a couple of reasons. Traditionally, when collets are made, they are slotted from one direction from the face up, and then in the opposite direction they're slotted from the rear back. So it creates this sort of zigzag all the way around that turns into the full circumference of the collet, and it gives it its springiness. I don't want to have to slot this from 2 different directions, and it would be quite a lot of work to do that. I have to create fixtures and whatnot. So if I can find a way to produce this on my lathe where I have a solid piece that it can be held by during the slotting function and then cut off and still all be one unit, it should be more than adequate. We'll test some before we stick some out there for artists to use. But anyways, that is what I'm doing here, and this is going to be a matter of just simply grabbing this face, let's make sure we're in the motor housing. That's where we're working. I'm going to grab this face and I'm going to extrude that -1 millimeter. That's all I'm going to do is push that cut upwards. So now if I turn the collet cavity back on, which is what I'm going to use as the final shape for the collet itself, now you can see that there's room for the collet to slide up a little farther before it hits this shelf, and that will allow for compression and the holding of the tube. So, but these are just little things when you're designing something, you're going to come across all these little things, and you got to sort of stop and chase them down while you're thinking about them, or make a physical note so you get back to them. But I find when I'm doing this is no better time than the present to just fix the problem. So heading off a future issue by doing that. Okay, so let's do this. I'm going to, I want to keep that original. So let's just duplicate that part. A duplicate feature? Nah, just a copy paste, right? Okay. Oops. And thought Control D was a duplicate before, but it isn't. Maybe they changed the software. All right. You know what? We'll do this. We will save as, and we saved as a component. We're just going to call it, oh, sure, overhead 3 collet, and we're going to save it in overhead 2 file. It's going to show up over here. Okay, so now that's a totally separate product, actually. So what we're going to do is we're going to insert this into here. We're going to turn off collet cavity, and let's see, that's in the exact placement we want. Perfect, done deal. Okay, so, oh, I inserted that into the collet cavity. So let's just drag that up to the top, and let's break that link. No, it's not going to let me break the link. I get frustrated because it doesn't want to tell me why I can't break the link. Selected instance has some essential dependent instances. Breaking link parent is not supported, blah, blah, blah. Okay, I don't care. It's a separate product. Okay. Let's just isolate this. This is what our collet will look like. We'll turn our analysis off. And come on. Edit in place. Okay, yes. Do. All right, so we're actually physically editing this part. Instead of opening it up separately, we're just going to open it up inside this this project. So all we're really looking to do here, well, a couple things. First of all, I'm going to put a chamfer on the front edge. Let's see, here, and let's do 1 millimeter, 1.5 millimeter on the front there. Then we're going to sketch on the face, and we're going to create the tube hole, which is 8 millimeters. Okay, let's finish that, and let's just extrude this all the way through. Okay, so this is the basic shape of our pinch collet, and let's see, at the same time, let's open that SketchUp we just had, and let's see, rectangle, center rectangle. We're going to do a center rectangle here. I believe the thinnest, um, slotting saw I have downstairs, I think, is a 32nd of an inch. So this is what's cool too, is the CAD software it's smart enough where I can physically just go 1 divided by 32 IN. It knows how thick that is. No, it doesn't. Yeah, 30313. All right, so very, very, very thin slice there. Maybe too thin. Let's go 1/8 inch. So 0.125 inch. That's way too thick. Wow. 0.0625. I know I have a 16th inch slotting saw. Why is it making that so darn tall? All right. Let's do it in metric because it's just not registering properly there. Okay, so center rectangle again. Let's do this. We're going to go 1.5 millimeter by 16. And then we're going to do the same thing in the opposite direction. Oh, forgot to grab a center rectangle. Okay, 16 by 1.5. There we go. Finish selection and turn that sketch back on. We're going to do another extrusion, which is going to be everything within the rectangles. Why not? We'll grab them all just in case we modify the file later. Okay, and we're going to go to an object, back to, is it going to let me grab that scene? Nope. All right, so let's go distance. Look at it from the side, and what is that? 12. Why is 12.1? I just want to get as close to this line as I can. So 2.5, good enough for government work. 2 is probably perfect, close enough. All right. So turn off that sketch now. Okay, so that's what our pinch collet will look like. And I can get that right off of the lathe all one shot because I've got radial tools. So the lathe will turn the outside shape, bore the hole all the way through and out, and then radial tool will come in and cut this slot, rotate it 90 degrees, cut the other slot, and then the cutoff tool will cut it right off of a complete part, one operation off the lathe. I will produce these originally. I think I'm going to try them in the aluminum, see how that works, because it'll be a springier material. I may make some out of Delrin too, just to see. The Delrin won't have as much springiness, but it might conform and get a little more grip on the tube, and it may be easier to get out if one happened to get wedged in there. So, all right, so let's exit our and edit in place. There we go. And let's isolate all except for that tube. All right, there we go. Oh, where is it? That's the collet cavity. I don't want that one on. Hmm. Are we just not forward to the end? What is going on? I look stupid again. Yay, me. All right, so what do we got here? Overhead 3 collet. Yes, we want to see that. That's on, bodies are on, sketches are off. This is the collet cavity itself, which is the blank one. Should not be showing there. I wonder, I did copy paste before. I wonder if I just didn't catch where it landed. Let's close all the components down and see if we don't have an extra one in here. Alright, if I was working in there, how many bodies are in there? Wouldn't make a difference because that's not visible. What is in here? How many bodies we got in here? Just the one? It is visible. Return. I think this might be one of those weird little glitches where if I just close out of the control save, okay, or save the project, I'm going to close it, I'm going to open it, and how much you want to bet it looks proper? I could be wrong. Nope. Again, I'm wrong. Okay, so did I paste one of those into motor house? Yep, I did. There it is. I knew it. I knew it. I knew it. I knew it. When I hit Control V, it pasted one. I must have had motor housing highlighted. So let's just delete that out of there. There we go. All right. So now when we're not viewing the collet cavity tool, we are viewing the collet. So now you're only seeing parts of this ring here because it's the sectional view, and it just happens to be perpendicular to the collet itself. But we can just quickly create another sectional analysis along that plane, and you can see that the collet is in fact in there. So maybe I'll go 0.5 millimeters. So it is in there. You can't see it because of where the slots are. All right, done deal. And ooh, you know what I want to do? I want to go back and I want to extend the face of this collet down so that this chamfer shows outside. So when the collet nut pushes, the collet nut is going to be pushing against a V at the same time that the collet itself's going into a V, and it should get more of an even compression on the collet. So little changes as we go. So let's see. Let's edit this in place again, and let's not edit that in place. Let's end edit in place. We're going to go to all the way up to the end here. That was the revolve for the collet, I believe. So that's the sketch for the collet. Okay, so there's the collet sketch. And all I need to do here is, I believe I had this line coincidental, so let's take that out. Now should be able to, not that line. Let's get rid of that coincidence. Oh, how is I going to get just this one line here? There we go. That's the line. I don't want these extensions on here. I want it, there we go. Come on, pull. Okay. Well, that didn't go as planned. Control Z. Let's extend. We'll dimension this to this, and that's adding this dimension will over constrain. Okay. That's because this is concentric with this line. Okay. Let's do this. Let's get rid of this line. Okay. Let's get rid of that constraint. Now let's see if we can just pull this down. No. Let's go back. What's constraining us here? We have 14 degrees coming through 10 millimeter base, 3 millimeters there, 13. Oh, this is what's constraining us. Now I can do this. Constrain, constrain, da 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 da. Let's go to 14 millimeters. There we go. Finish. And cavity shouldn't have changed, but everything else that was related to it should have changed. So let's look at our collet now. Let's isolate that. Nope, that didn't work the way we wanted. Not a big deal. All right, let's isolate that. We are isolated. What's going on? Let's just do it the old-fashioned way. All right, analysis off. I hate this. I'm not familiar with this feature. All right, turn analysis off. Now I'll edit that in place. Why is analysis still on? And edit in place. Analysis on, analysis off. Glitchy shit. Alright, so edit in place. Let's go back to before this, before this, before this, before this, before this. There is no sketch. Oh, the sketch is hidden because it's linked. Alright, so revolve, chamfer, chamfer. Before the chamfer, we're going to simply add some material here, 1.5 millimeters. Okay. Now that chamfer there, 1.5, there. Should be able to do the rest fine, except for this sketch needs to be placed on this face now. Okay, now my slots are going to need to be extended 1.5 millimeters, so not a big deal. We were at 12.2, so we go to negative 13.7, and we have a deeper cut slot, and we're good to go. And we can exit out of there. And let's see, unisolate all. Why am I not getting the features I want? Does anybody see this and I'm not seeing it? Because remove all visibility overrides. Wow, did they just like rename that all of a sudden? Okay, pusher bar, motor cover, motor mount, bearing, cam, RCA, motor housing. All right, and let's hide that grip. Oops. All right, so here's where we are. Now you can see the collet's going to extend down just a little bit. And the next thing we're going to do is, what was the, can't remember the diameter we used on this, 18 millimeter, I think. Yeah, that would be it. Okay, so now we're going to create the new product, the collet nut. Let's call, let's see, yeah, we'll just call it collet nut. That's what it is in the real world. Okay, so collet nut. We are going to create a construction offset plane. Let's turn off the collet nut, and we're going to work right on this very, very, very front face here. And we're going to go 1.5 millimeters forward because that's the amount of material we added to the front of the collet itself. Just confirming that the plane is down where I want it. And let's sketch on that plane. We are going to do, all right, what do we know? We know we need 8 millimeters to come through. We'll give it a little bit of clearance here, so go 8.2 millimeter circle for clearance for the tube to go in. Then we will come out to, we know our thread diameter, we're going to need 18 millimeters in here. And then we're going to need some thickness around that. Then we're going to need extra thickness so that we can create some sort of ribs or flanges or something on the collet nut that you can grab comfortably with your hand, tighten and loosen. So let's add 6 millimeters per side, 12. So we're going to go with a big fat 30 millimeter nut. We'll probably back that down a little bit, but let's go with 28 millimeters. So that's a little over an inch in diameter. That even seems big. 26. Let's go 26. And again, we'll adjust it based on what it looks like, what we think it's going to feel like, and a few other things. Okay, so at the same time we do this, you know what? I'm going to do another sketch for that when I'm done creating the basic form. So what we're going to do here is we're going to grab, we're going to extrude this face and this face. We're going to go, we'll get down a millimeter. And then we're going to turn around. We're going to make sure that sketch is on again. And from the top side here, we're going to extrude this face. Let's see. What this distance is here. And let me grab that. That is 11.5. All right, so 11.5 fully seated. I probably just bump it to 12. Distance minus 12. All right, because we will play around with it a little bit. All right, let's isolate just the collet nut. That's all we want to see for right now. And let's put a chamfer on the inside of 1 millimeter, 0.5, 1.5 millimeters there. And let's see, what else will we do? Put a very, very thin chamfer on the front here of 0.25. That really just breaks the edge. And let's put our threads inside. On this surface, I believe we went with 18 by 2 millimeter thread. Let's model them, make them look nice. Full length. I can't quite machine the full length, so we'll handle that in the machining aspect. Okay, so now that's a basic shape. Looks pretty good. 12 millimeters. Let me just, sometimes I need a visual reference, so I'm going to grab my digital calipers here. Quickly open that up to about 12 millimeters. And that's not even as thick as my pinky, so I'm not sure if that's going to give enough room to hold on to. So let's back up to this one, and this extrude here, -16. Let's make that a little taller, and we may go back and modify the threads on the machine base itself to accommodate that. Now that chamfer there is looking a little deep, so let's back that off to 1. It's the threading that's making that. Okay, giving us that appearance. All right, so quickly we will just unisolate all, activate that. Let's see what we got here. Oh, looks again like a bad Lego. Sharp edges, step on that in the middle of the night, you will not be happy. Okay, doesn't look terribly visually appealing, but we're nowhere near done. So let's call it, not turn that sketch off. Let's hide that for a moment. This threading, I want to go back to motor housing, this whole history. Where's the thread? This extrude, this extrude. All right, so whatever I add to one, I got to take from here. So that was 7.5 on the secondary extrusion, I think. And so if we make the threads just a little longer, let's go to 12 on them. Oops. -12. And that looks a little cooler. Now, I want to see where this is going. 5.5. Okay, let's turn our collet nut back on and activate that. Okay, that looks a little meaty for the collet nut, but we can thin that down just a little bit. Let's see where the let's go back to that and let's go down to 24. Get the home view, activate, and that looks a little cleaner. Now, all right, and let's put some fillets on this. This is where it starts to get a little more fun. 3 millimeters. That kind of what we got up here. All right, so then that kind of gets into our chamfer there. We can play with that chamfer depth a little bit in the machining aspect though. Okay, so we did that. Let's create a new sketch down here. And we're going to now create the reliefs, sort of like the finger grooves for the collet nut to tighten the tube. So let's do, we're going to 19 millimeter inside radius, because I know that'll be larger than the threads and leave enough material still. So that'll be good. And create another circle straight up off the top here. Let's see, how big of a relief do I want here? Generally, I've been doing, well, let's do 8mm relief. Okay. And we're going to make this relief tangent to that 19mm line we just created. And we're going to create a circular pattern of this item around this center. We're going to do 5 of them because I almost always do 5s when I do relief cuts. Oops, actually, let's back out of that because what was this diameter again? Come on, Mark. 24. Okay, so let's go back to this. I do 24, and I'm going to trim this outside circle, this inside line, and let's see, I'm going to use the drawing fillet to do that. Let's go 3mm on there, 3mm on there. Call that good, and now we're going to create our circular pattern. And what we're going to do is take this line, and this line. We are going to revolve that around that center, 5 total units, and click OK. All right, so now I'm going to create one more circle, which is just going to be, well, let's go 30mm for fun. Finish sketch, and this is where things get kind of cool. Turn sketches, I want that sketch off, the sketch on. We're going to extrude the shape that we just created. We're going to extrude the distance to object up until that line. No? All right. Let's just pull it up. Get it up past the whole nut. Bam. All right. That looks kind of cool. I'm not sure I like the way it cuts down into the chamfer, but this is, let's change that chamfer to 0.25 and just see if that makes a difference. There we go. Now these reliefs don't quite get into that chamfer line, and it looks pretty decent. I'm relatively happy with that. Simple, functional, a lot of curved edges, not a lot of sharp edges, like so it doesn't want to dig into the fingers while you're tightening it. Might be a little big on the diameter, and the only reason I worry about that is because people like to over tighten things. But honestly, I think that should be okay. After I make some and play with them, I can go back and make adjustments. So, all right, so there we go. What did we do today? We let's turn everything on. Let's look at it from the front. We have a front analysis. No, that's we didn't want to keep that one. This is going to be our side view analysis. Let's do one from the front. Sectional analysis from this face. Okay. All right, so our tube's up too high right now. Again, little things we can adjust. We may end up shortening the body to accommodate that. We don't want this to be too overly long entirely, but guess what? It looks good because our collet nut presses against our, let me turn off the tube. Okay, so You can see our collet nut, represented by the pink here, will press against the face of the collet tube. This is something I didn't either. I've got to put this angle into the bottom here, and then it will compress inwards while it pushes upwards. So I'll go back and do that here. Well, you can see what's going on. The tube comes up through the center of the collet. It comes up as you tighten the collet nut. It pushes the collet nut deeper into the wedge. It compresses against the tube, and that's what holds it in place. Easy enough. The side view should be very similar, except for you can't really see the collet because the slices come right through that very same place. So, all right. I hope this one wasn't too terribly long, but we made a little more progress. I think the very next one we do will be going through and wait 1 second. This is why you look at things from different angles. All right, now I have enough material there, but honestly, I may, yeah, let's do it. Why not? Let's, not the collet. Let's get to the collet nut. Edit that. This is the diagram here, the drawing we did here. This one here is 19. Let's go 19.5. Add just a tiny bit more meat to that. And finish. And right side. And just like that, we thicken this up. Not much, 1/4 millimeter on each side, but makes me feel a little bit better about it. On the thin sides where the recesses go, it gets thinner. The cuts get closer to the threads, but where it's larger, it's plenty meaty. So, okay, so let's measure this angle while we're in here. Why not? I know I get close to saying, oh, I'm done, but then I go do something else. So what's that angle? It's not going to give me that angle. Okay, so let's go into the edit in place on the collet. Let's hide the collet nut, and I just simply want to measure the angle between this face, this face and this face. Is it going to give me an angle? No, it's not. Close, easy enough. We shall sketch on this surface, this plane, and quickly kind of project that line and this line, and then we will dimension, or let's do this. Let's extend. Not going to let me extend that line. Okay, fine. We'll do the math backwards. Okay, so we're going to measure between this and, come on, this. No, I want, grab it. I want you to give me a dimension between that line there, between this line and this line. Okay, fine. Gonna let me measure it anyways? All right, let's break link. You're not gonna let me break link? Did we project that one to start with? Let's hide the bodies. All right, I can see 2 lines, right? I'm not crazy there. Dimension this line. You know what, let's just draw another line. It doesn't want to recognize that line? Fine. We won't. 135 degrees. Yeah, that's what I thought it was, but I just wanted to be sure. Okay. Finish sketch. Let's just delete that sketch. Okay, so 45 degrees is what that is. So that makes things just a little bit easier. Edit that, get out of that. Back into the collet nut. We're working on the collet nut. Let's isolate it so nothing else is around. And we're going to back this all the way up to here. We're going to, in fact, we're going to make this 2.5 millimeters and extend up to this. And the very first nope. Control Z, Control Z. There we go. Add this in. I want to extend this up 1.5. Then I want to, what was the outside diameter of our collet? Oh, I can just do it on the collet cavity. And hide the collet nut and inspect this diameter, which is 13 millimeters. Okay, close, turn the collet nut back on because that's what we're working on. Hide the collet cavity. Create a sketch on. Nope. It's not what I want. Finish sketch. Delete sketch. Delete that extrude. Again, it's a never-ending battle. Okay, so what I want to do now is on this interior, I want to create that 13 millimeters circle from the center out 13. Okay, and then I believe I want to extend this up 1.5. Then I believe I want to put a chamfer of 1.5 on that. Now let's see if this did what I thought it was going to do. Unisolate all and close. The heights are off just a little bit, but you can see where the chamfer I just put in the face of the nut now is going to connect really well with the face of the collet. So all I want to do is, well, I don't have to do anything actually. As the nut tightens up, it'll just move up that 1.5 millimeters before it makes contact. Then that will come a little slide a little higher up the machine body, and there will be less of a gap there. So, all right, let's see. I'm going to say, let's activate that. That's where we're at. And again, I dragged it out way too long, but it takes me a lot longer to do these things while I'm kind of walking you guys through it. You guys can see by now that my mindset, my ideas, my plans change quite fluidly while I'm going through this, where I have an idea and I start down that road and it doesn't work. Or it will work, but I don't want to go there for one reason or another. Either it's going to overcomplicate things or, and the truth is I'm really just spitballing this. Most machines I'm designing and stuff, I spend weeks and weeks and weeks on, just in the concepts and the the basic designs, and then there's more weeks and weeks and weeks during the final detailing, and then the prototyping and all of that fun stuff. So, but we're moving along pretty good here. I want to say thanks for watching again, and check it out next time. We'll start smoothing this thing out so it looks a little more appealing, and then we'll go into production. Thanks for watching. Okay, this thing is really starting to look like something now, so I'm getting a little bit excited. Stay tuned for the next episode.